Section 2.3, we're going to do this one in two parts also, and the vocab and definitions are getting pretty heavy, so like I said in the last few lessons, if you have a note card that you might want to put things down on to help you remember, but vocabulary and geometry is extremely important, and you really need to understand what each word means, what each term means, to help just understand the lesson as a whole. So first I have deductive reasoning. Deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. I believe that's why some students do much better in geometry than they may in algebra, because geometry, if you have some logical skills or your ability to argue or defend or come up with reasoning, you can do a little bit better in geometry, or at least be more comfortable in geometry. So different from inductive reasoning, deductive reasoning is much different than inductive reasoning, because inductive reasoning uses specific examples and patterns. There's a typo. Patterns to form a conjecture. This is just another example of the laws of logic. Law of detachment. Okay, we're going to use this word as our lesson goes on. If the hypothesis of a true conditional statement is true, then the conclusion is also true. So if the hypothesis of a true conditional statement, remember conditional is if-then, is true, then the conclusion is also true. Makes sense, right? The law of syllogism. Sorry, I pushed pause for a second. So that is the law of syllogism. I wasn't sure how to say that word, and I didn't want to make an idiot of myself, so I asked someone, and I'm saying it correctly. It's just a very strange word. So the law of syllogism, if hypothesis P, then conclusion Q. So if hypothesis Q, see how those are connected? Then conclusion R. So you can say that if hypothesis P, then conclusion R. Do you see how you have like beginning, middle? The middle becomes the beginning to the end, so you can say beginning to end. And I have a good illustration we'll go over in class tomorrow, but pretty cool. So law of detachment and the law of syllogism. First example, use the law of detachment to make valid conclusion in the true situation. First example, if two segments have the same length, then they are congruent. You know that BC equals XY. Our solution, okay? Because BC equals XY satisfies, nice writing there. Sorry, it always looks like my 4-year-old did this. Satisfies the hypothesis of a true statement, of a true conditional statement, if then. Remember, conditional is if then. The conclusion is also true. So BC equals XY. Okay, if two segments have the same length, they are congruent. And you know that BC equals XY. BC and XY are two segments. They're equal. To read through this explanation, because BC equals XY satisfies the hypothesis of a true conditional statement, if, then, the conclusion is also true. So BC equals XY. It's like you're just stating the obvious. Another example, use the law of detachment to make a valid conclusion in the true situation. Mary goes to the movies every Friday and Saturday night. Today is Friday. So first, I'm going to identify the hypothesis and the conclusion of the first statement. Oops, pen. The hypothesis is, if it is Friday or Saturday night. The conclusion is, then Mary goes to the movies. Okay, so use the law of detachment. Today is Friday. Satisfies the hypothesis. Satisfies the hypothesis. So we can conclude that Mary's going to the movies. Pretty simple. It'll be harder when you try to do one on your own, but read the answer is pretty simple. If possible, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. Okay, if Rick takes chemistry this year, then Jessie will be Rick's lab partner. If Jessie is Rick's lab partner, then Rick will get an A in chemistry. Okay, so remember the law of syllogism said, like, if P, then Q. If Q, that's not a Q. Sorry. Goodness. If Q, then R. If P, then R. Okay, so we can say that if Rick takes chemistry, then Rick's going to get an A. Pretty cool conclusion, I guess. I'd take chemistry if I were Rick. Okay, next example. If possible, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. If x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. Here it's sort of not in the same order as our examples, but we see that my beginning is the same as my end. So how I thought of this is I need the middle statement. Okay, so I'm going to say if x squared is greater than 20, then x is greater than 5. And that sort of makes sense. If you remember our examples, we would get beginning to the end, and then we'd use this for the beginning to the next one, and then beginning to end, and these always match. Okay, let's try this last one. If possible, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. I'm going to color coordinate this the best I can. Let's do red. If a polygon is regular, then all angles in the interior of the polygon are congruent. Then we're back to the beginning. If a polygon is regular, and here I have a different conclusion, then all of its sides are congruent. Okay, and let's go back to the beginning. Remember, we would say if P then Q, and then we could say if Q, then R, and that'll get us back to the beginning. If P, then R. Let's see if we have that pattern. So here I have if Q, if P, then Q. And then I have if P, then R. So we're really missing this middle one again. But let's say what would be in the middle. I could say if all angles are congruent, green, then all of its sides are congruent. Yeah, that doesn't work at all. Okay, if all angles are congruent, you can't make the conclusion that all sides are congruent. So that doesn't work. Neither statement's conclusion is the same as the other statement's hypothesis. So you really can't use the law of syllogism to write a new conditional statement. Okay, I have a conclusion in blue. It's not the same as the hypothesis. I have a conclusion in green. It's not the same as the hypothesis. So the law of syllogism doesn't work. Sorry. I'm going to push pause and write it so you guys can write it after me. Okay, neither statement's conclusion is the same as the other statement's hypothesis. You cannot use the law of syllogism to write a new conditional statement. Okay, neither statement's conclusion is the same as the other statement's hypothesis. Go back. Let's move on. Okay, you try this one. Okay, you can go back and review the work we've done, but try it on your own. The law of detachment seems a bit easier than the law of syllogism, so the statement we can make here is angle R is obtuse. Another you try, push pause. This one's pretty easy. If Janelle gets a job, then she can afford a car. If Janelle can afford a car, then she will drive to school. So, if Janelle gets a job, she's going to drive to school. State the law of logic that is illustrated. Push pause and try on your own. If you get an A or better on your math test, then you can go to the movies. If you go to the movies, then you can watch your favorite actor. Therefore, if you get an A or better on your math test, then you can watch your favorite actor. Law of syllogism. Last one, on your own. We have the law of detachment here. Very cool. If x is greater than 12, then x plus 9 is greater than 20. The value of x is 14. So, x plus 9 is greater than 20. Awesome. Taking a break, okay? You can watch part 2 tomorrow night. Nice work.